guys, welcome to this teaching segment. I'm about to guide you through the resolution of the question that got before me. I have systems of linear equation given to me, and we are going to solve these systems of linear equations using Gauss-Jordan elimination method. And I'm going to give you a smarter approach that's going to help you to solve the question pretty quick, and from there you'll be able to have a firm control and firm grip on the resolution of questions like this using Gauss-Jordan elimination method. Now, before I proceed, I would like to quickly guide you through to show you what we are going to encounter if you have a question like this. The first set of things you have to do, we have to extract the values of x1, x2, x3 in the rows. We see you can see that we have three systems of linear equation. The first one, 2x1 minus 2x2 plus x3, and just like the way we wrote, got it down to the bottom here. So the first thing we're going to do in solving this question is to extract the values of x1, x2, x3 as we're given in the equation. So I have from here, I have 2 extracted here, minus 2x minus 2x2. I have minus 2 here. Then I have x3 is 1. So it has been depicted in this place. Then the outcome of this linear this equation here is 3. So it has been written in the augmented matrix shown in this place. Now the same thing goes for 3x1, 3 in this place, x2 is 1, x3 is minus 1, and their value corresponds to 7. So I have 3, 1, negative 1, and 7. That goes for the lowest equation that we're given to. I have x1 minus x minus 3, 2, then 0. So it has been extracted out in this place, 1, minus 3, 2, and 0. So these three form a perfect matrix, and given 3 rows in the outcome that we have in the course of extracting the values from the system of linear equation we're given. So at the end of the resolving this matrix, we are going to have it in the reduced form. When we reduce that, we will have a set of diagonally placed ones that's going to reflect our answer, and 0 at the 3 angles in this place. Then also at these 3 points, you're going to have them in form of submatrix. Then our final answer for x1 is going to be 2, 0, and minus 1, just for this question. So at the end, you're going to have 0 at these 3 points, 1 written all through diagonally, then 0 at this 3 point here. So that shows that you have reduced the matrix into what is expected of you. So what I'm going to do now is now take you through the resolution. That is how we move from this point to this point, and we arrive at our final answer. So just stay with me as I take you through the solution, and everything will be good. So to start with, I'm going to prepare a new augmented matrix from the values I have. So I'm going to put this aside, and the new augmented matrix will be drawn out from the question that I was given. So that will be written in this way. This is my new augmented matrix. Just like I said, for first row, I have 2, negative 2, and 1, then 3. So I'm going to write it out this way: 2, negative 2, 1. Then for the augmented part, I put dotted line, then write 3 on that side. So for the second row, I have 3, 1, negative 1, and 7. So that is 3, 1, negative 1, and 7. Then for the third row, I have 1, negative 3, 2, and 0. So that will be written out as 1, negative 3, 2, and 0. So that goes this way, and you are through with your augmented matrix. So we are now dealing with the augmented matrix. I'm going to put this one aside because we already extracted the values of x1, x2, x3 across the row. So we now go forward with the solution, getting our answers. Pretty fine. So the first thing we're going to do, we want to arrive at a solution like this. 1, we're going to have 1 across the diagonals, 0 at the 3 point here, and 0 at the 3 point here, then have this. So the first thing we're going to target is to focus on how to get 1 at this leftmost side of the matrix. So I have 2 here, I have 1 here. One of the things you could do is to swap rows. When you swap rows, you get your answer. You could swap the 1 that is at the bottom of row 3, the entire row up. So that is like swapping row 1 and row 3, so that we can have 1 at this side. So I have, this is row 1 and row 3. So let's swap row 1, R1 and R3. So for that, we're going to have 1, negative 3, 2, then 0. Then we'll bring that row 1 down. So in that case, we're going to have 2, negative 2, 1, 3. Now the middle row will not change. I have 3, 1, negative 1, and 7. So you just put that back. 3, 1, negative 1, and 7. Now with this, you have been able to achieve putting a 1 at the leftmost side, just like the way we are approaching our answer of a reduced matrix. So I have 1 here already. So the next step we're going to do is to see how to get 0 at row 2, column 1, and row 3, column 1. So that your answer will be very easy. Once you get a 1 here, then target these 2. Immediately you're going to perform a row operation that is going to solve these 2 at the same time. You don't need to solve them one by one. It could get cumbersome. So you target these 2, row 2 and row 3, and from there you're good to go. So let's see how we move forward to change our row 2 and row 3 into 0. We want to change our row 2. So this is what we're targeting, our row 2 and row 3. We are looking for how to change them to 0. So we're doing that. We're going to form 2 equations that we're going to have. For row 2 to change to 3, to change to 0, we're going to multiply row 1 by negative 3 and subtract row 2 from it. Then, and that will apply to everything across board. Then you also do that for row 3 too, to change it to 0. So we're going to have row 1 multiplied by negative 2, and whatsoever you have, you're going to multiply that across board. So let me write a system of equation that we're going to use. So here I'm going to have negative 3 R1 plus R2 will give us the new R2 row. Then for our row 3, we'll treat that equally to, this is for row 2. Then for row 3, I have negative row 2 minus row 1, then plus R3. That is going to give us the new R3. I believe you can see that. So this is what we're going to use to advance to the next level of solution. So the new augmented matrix I'm going to have is going to give us I have 1. I will write 1 all through. So that is 1, -3, 2. I have my dotted and I have 0 here. So with this value I was given, -3 multiplied by 1, that's -3 plus 3, that's going to give us 0. So this has changed to 0. So -3 multiplied by -3, I have 9. 9 plus 1, 10. -3 multiplied by 2 minus 6. Minus 6 minus 1, that's -7. Then -3 multiplied by 0, I'm going to have 0 then, plus 7, that still remains 7. Then for row 3, column 1, I have -2 multiplied by row 1, that is by 1, and that's going to give us -2. -2 plus 2, that's going to give us a 0. So the same goes all through, and we're going to have 0, 4, -3, and 3 using that formula. Using that to reduce that matrix. So the next thing we're going to do, the next operation we're going to perform is how to change this 10 into 1, so that we can start working on getting our 1 diagonally. And the formula we're going to use is R2. R2 will be equal to R2 divided by 10. So once we have used that equation, we're going to have a new set of augmented matrices that says I will have 1 written in the row 1 written the same, 0. So then row 2 that we targeted, that's 10 divided by 10. I'm going to have 1, and minus 7 divided by 10, I'll write that in decimal form, 0.7. 7 divided by 10, I have 0.7. Then I will write row 3 to be the same. So the next set of things I'm going to do now is to change column 1 and column 2, row 1, and column 2, row 3 into 0. Now that I have 1 at the center. So what I'm going to do now is to write a new formula I'm going to use to reduce that. So I will have 3R2 plus R1 equals to R1. I have 4R2 plus R3 equals to the new R3. So that is what I'm going to use to reduce the row 1 and row 3. Row 1 and row 3, column 2 into zeros. So now I'm going to use this. So I have the new augmented matrix. I have 1. Now 3 multiplied by row 1 multiplied by 3R2, that is 3R2 will give me 3, then plus R1, that's going to give me 0. So I have this in form of 0. I have the same thing. These are the new answers I'm going to have. Yes, minus 3, I have a 0 there. Then 3R2, this is going to give me a negative 0.1. I have this 0, 1, negative 0.7. Then I have my dotted line, that is 0, 0.7. I just have to rush it up. Then for my new order here, I have 0, 0, negative 0.2, and 0.2. So gradually I'm getting towards the end of my equation. I already have 0 at this 3 point, 0 at the top, so I need 0 here. Then I need a 1 here. So to do that, to get 1 at that point, I will raise a new formula. This 0.2 is like saying 1 over 5. So for the new formula I'm going to use to reduce that is negative 5 R3 will be equal to my new R3. So it's just like saying 1 over 5 times negative 5, because this is negative already. Okay, so if I cross this out, I'll have a 1. So I'll write that out. That's going to give me 1, 0, negative 0.1, 0, I have 0, 1, negative 0.7, 0.7, then I have 0, 0, then at this point I already have my 1, then here I'm going to have a negative 1. So having 1 at this point, the next thing I'm going to do is to find a way to reduce these two values into 0 instantly using R3 as my pivot point. So I'm going to have a new formula that I'm going to use to reduce that. So let me generate the formula. I have 0.1 R3 plus R1 will give us the new R1. Then 0.7 R3 plus R2 will give me the new R2. So that settles that with 0.1 of this multiplied by this. 0.1 multiplied by 0.1 is going to give me a 1 instantly. So plus R1, I'll have my 1. So the new set of value I'm going to raise from this equation is going to be from this value that I got now. I'm going to have a new augmented matrix that says I'm going to have the 1 here all through. So 0, 1, 0. So because I say 0.1 multiplied by R3, my R3 is 1. So then plus the minus negative, so this is going to give me a 0 instantly. Then I have my augmented. Then using that, I'm going to have new set of values: 0, 1, negative 1, 0, 1, 0. I have 0, 0, 1, and that perfect the final answer that I'm supposed to get. So with this, the solution to this system is going to be x1, x2, x2 is 0, and x3 is negative 1 for my final answer. So we have this as the three solutions we got from the reduced value. So we have 0 at the 3 point, 0 at this 3 point, and 1 written diagonally, and that settles what we'll be working towards. So this is a simple way to go about Gauss-Jordan elimination method. And if you apply this, I believe you'll be able to arrive at your answer very easily. If you like this video, you can subscribe on my channel, and you're going to get more of this video. So thank you for watching. God bless. Bye.